this video, we are going to discuss about seventh experiment, which is nothing but interfacing of memory modules with our FPGA boards, and then verifying the design functionalities by probing the internal signals. And we are going to study this particular experiment by the way of interfacing memories with FPGAs. Memories are nothing but a block of RAM, random access memories, which is used for storing large amount of data for our FPGA. And there are many 4 identified components inside our FPGA datasheet, which is acting as a memory module. These are flip-flops, lookup tables, the digital signal process DSPs, which makes our FPGAs more bigger and expansive. And the more block RAM, the more expansive FPGA will have more block of RAM. The top of the FPGA product will be consist of this particular memory. As an example, we can see the memory value of our Cyclone V5 FPGA. See, this particular block RAM is having 176 and 308 block of memories, and it also contains registers and precision DSP blocks alternatively. See, next, what is this block RAM? Block RAM indicates which is nothing but embedded memory, which will be available on the chips and have different amount depending upon your applications. And this particular block of RAM has a finite size like a 4:8 or 16:32 kbs are common. And here comes the structure of our single port BRAM block of RAM. Here the default input probing signals are clock, address, and write data, read data, and write enable. And once the input data are addressed and stored inside this particular RAM, we can able to read that particular data from the output. And here writing the data will be acting as an input, and reading out the data will be acting as an output. Once if we programmed our FPGA, it will be fixed whichever will be the address or location of that particular read and write operations. And there is a bunch of calibration has been needed once we implement this particular RAM inside the FPGA. And we need 8B or 10 byte of encoding and decoding for Ethernet, USB and all. That will be a great application for our single port RAM block. There are also a clock and address which we already discussed. So next one is our dual port BRAM block of RAM. Here you can find there is 2 different sets of ports, port A and port B. In port A, you will be having separate clock signals, write enable signal, address signal, write data, read data and all. In port B, we will be having separate clock signal, write enable, address signal, write data and read data. And if you want to use storing data in an external device, you can go for reading the data and writing the data in SD cards, which is a dual port RAM. And we can also interface this particular RAM with an ADC, analog to digital converters. Additionally, our dual port RAM is commonly turned into FIFOs, which are probably one of the most common use of block RAM and FPGA. And here we can find the FIFO BRAM configuration. FIFO is nothing but logic which is used for organizing the data, that is first input and first output. Here in the right side, right means what is the data we need to store. In that right side, we will be having probing signals like clock, write data and write request, then and replay signals like full and almost full. Once we found this particular fill is highlighted, we can stop the process. And in the read side, we will be finding clock, read enable, read data. And once all the process completed, that is the entire reading process is completed, we can find that empty and almost empty signals will notify us. And in all our FPGA design, we are about to use a first in, first out, since this will serve as an important block in RAM FAFO. And how to create this particular RAM in VHDL or Verilog. Here are some of the choices. We use GUI, that is graphical user interface in Vivado, interactive GUI in Vivado, and this method is great comfortable with BRAM. It can be fall apart for larger designs, and also we can infer this large memory in Verilog, uh, uh, and we can use Verilog VHDL for beginners. If you have if you have FPGAs to be interfaced with memory, this is a strong recommendation that we can go for Vivado for implementing the memory modules in FPGA, and we can analyze particular design by probing the internal signals. In Vivado tools, we will be having separate memory design for FPGAs. It will be useful for us to interface. Thank you.